Hello everyone, welcome to Tech-Lavya. Please like, share and subscribe.
We are solving May 2019 question paper. We have already solved two parts and this is going to be the concluding part, that is part 3. So till part 2 we have solved till question number 5a and now we'll be discussing question number 5b, which has been asked for 8 marks. So they have said that in the following circuit find the value of R for maximum power and also calculate the maximum power. Okay, so first let us see how the circuit is. So here we have 10 volts, 2 ohms. It means actually the voltage source, the magnitude of the voltage source, or that voltage source supplies 10 volts and its internal resistance is 2 ohms. Okay, so how are we going to represent it? Here we have R and 10 volts. So this is how it is represented. Then we have 5 ampere, fine, and 2 ohms. Okay. So now what we will be doing is, we will be simplifying the circuit. Okay. So first we will be simplifying this and next we will be simplifying this. Okay. So how do we simplify it? So we will be using source transformation method. So this is a voltage source with an internal resistance. So this can be simplified into a current source having the impedance in parallel. So what is going to be the magnitude of the current source? It is voltage upon resistance. So 10 upon 2 comes out to be 5 ampere and this becomes 2 ohms. So we have simplified this 10 volts voltage source. Further, we will simplify this. So this is a 5 ampere current source with a parallel impedance of 1 ohm. So what we will be doing is, we will be converting this into its equivalent voltage source. Okay, so current is flowing from left to right. So minus comes to the left and plus comes to the right with a series impedance of 1 ohm. So this was 1, right? So here we have 1 ohm. So what is going to be the voltage? It is current into resistance. So it is 5 into 1. So the magnitude becomes 5 volts. Okay, so we have simplified till this point. Fine? Yes. So now let us move ahead. So we will be replacing this and then we will be drawing the circuit diagram. Fine. And in order to find the maximum power, we have to open circuit this branch. Okay. So how will my new circuit look like? So here I have a current source of 5 ampere with a resistance of 2 ohms. Further, I have a resistor yes. Then I have another current source of 5 ampere, right? We had actually replaced these two. So this 5 ampere will remain as it is and 2 ohms. Now we shall be replacing the current source of 5 amperes. So this is 5 volts and the value of resistor is 1 ohm. Okay, and the remaining part is as it is. So it is 2 and 5. And here it is VTS. So we will be actually converting this into Thevenin's equivalent circuit first. So see, this 5 ampere and this 5 ampere, the current direction is the same, right? So the current will be added and it makes it 10 ampere. Similarly, this 2 ohms is in parallel with this 2 ohm. So that can be reduced into a single resistor. So what is going to be parallel combination of 2 and 2? So it will be 2 into 2 upon 2 plus 2. So that comes out to be 4 upon 4, 1 ohm. So now here we have 1 ohm. So we have reduced this part. Correct? Further, yes. So the next part is as it is. Now what we will be doing is, now again we will be converting this into voltage source. Okay, so what will be the voltage source? It will be 1 ohm with 10 volts, right? So it is 10 volts and 1 ohm. Okay, so now my circuit would be ready. So what I'll do is, I'll erase everything and now I'll be making my final circuit. So this is 10 volts, 1 ohm. Then I had 5 volts, again 1 ohm, and then 2 and 5. So this is 5 volts, this is 2 ohms, and here is my VTH. So what we will be doing is, we will assume this current to be I, correct? So what will be VTH? VTH will be in this direction. So let us first understand what is going to be VTH. So this current I flows till this point, and here it is open circuit, so it does not go here, and the same current flows through 2 ohms also. So what is going to be my VTH? It is going to be 2 into I plus 5. So in order to calculate VTH, first we have to calculate I. So let us apply KVL in this loop. What is going to be the KVL equation? KVL equation will be 5 minus I. Okay, I'm starting with this portion. Okay, it is 5 minus I, because the resistance is 1 ohm, so I'm not writing that. Then it becomes minus 2I minus 5 plus 10 minus I is equal to 0. Okay, so this 5 and this 5 get cancelled. See, 5 minus I, yes, so this is 5 minus I, minus 2I, minus 5, then plus 10 minus I. Okay, fine. So this I, this 2I, and finally this I are added together. So we get minus 4I plus 10 is equal to 0, or 10 is equal to 4I, or I is equal to 10 upon 4. So the value of I comes out to be 2.5 amperes. Right? So I have now current with me. So can I calculate VTH now? Yes, I can calculate that. It was 2I plus 5. So I shall be putting the value 2 into 2.5 plus 5. So the value of VTH comes out to be, this becomes 5. So it comes out to be 10 volts. So I have VTH with me. So the next step would be to calculate RTH. Okay. So in order to calculate RTH, the next step is RTH. We will be short circuiting all the voltage sources and open circuiting the current sources. So here we have 2 ohm resistor, again 2 ohm resistor, then 1 and 2. So this 2 and this 2 are in parallel, and we know that the parallel combination of 2 and 2 gives us 1 ohm. So now it reduces to 1, 1 and 2. Here is my RTH. Okay, so this is 1, 1 and 2. So again this one and this one are in series. Here is my RTH. Right? So I have 2 ohms in parallel with 2 ohms finally. So this is 2 and 2, which is RTH. So RTH is again the parallel combination of 2 and 2 ohms. So that comes out to be 1 ohm. It means that for maximum power transfer, the value of resistor should be 1 ohm. So one answer we have found out. Okay. So what is going to be the next part? The next part will be the maximum power. So what is the equation for maximum power? It is V square TH upon 4 RTH. So this was 10 square upon 4 into 1. So that makes it 100 upon 4. So the maximum power comes out to be 25 watts. So this is my answer. Fine. Okay. So let us go to the next question. So the third part of question number C, which was asked for 4 marks, says that two impedances, okay, are connected in parallel. Fine. Across 230 volts. Okay. Single phase AC supply. And we have to find all the powers. All various powers we have to calculate. So what we will be doing is, first we will be writing Z1. So Z1 is 12 plus J16. Okay. Z2 is 10 minus J20. Okay. So since it is in parallel, I will be calculating Y1. So Y1 will be 1 upon Z1. Okay. So when I do that 1 upon Z1, I get the value to be 0.03 minus J 0.04. So this is in rectangular form. I will convert it into polar form and I will be getting 0.05 with angle minus 53.13 degrees. Okay, so I have done calculation for Z1 and Y1. Similarly, I will calculate Y2, which is 1 upon Z2. Okay, so when I do that 1 upon Z2, I will be getting it to be 0.02 plus 0.04 J. Again, I will convert it into polar form. So I will be getting 0.045 and angle comes out to be 63.43 degrees. Okay, fine. So how do I calculate current now? Had it been impedance, I would have written V1 upon Z1. Now since it is admittance, I have to multiply it. So I1 becomes V into Y1. Similarly, I2 becomes V into Y2. Now why I have written V? Why not V1, V2? Because this is a parallel branch. So the voltage across parallel branch remains same. So V is 200 and the value of Y1 is 0.05 angle 53.13. Okay, fine. So that comes out to be 10 minus 53.13. This is I1. Similarly, I will calculate I2. So this is 200 multiplied by Y2. Y2 was 0.045 and angle was 63.43. So my I2 comes out to be 9 and angle is 63.43. Okay, so I got I1, I got I2. So now what we will be doing is, see, this is phi 1, okay, and this angle is phi 2. So what is going to be the next step? We will be calculating the power factor. Okay, so in order to calculate power factor, we require phi 1, right? So for the first part, power factor is cos phi 1, and for Z2 the power factor is cos phi 2. Okay, so it is cos minus 53.13 and here it is cos 63.43. So this power factor comes out to be 0.6 and this power factor comes out to be 0.5. Okay, so how do we calculate active power? Now active power again will be 2 because here we have two circuits. So we have P1 and P2. Similarly, we will have reactive power Q1 and Q2. Similarly, we will have apparent power S1 and S2. So what will be P1? Come on, it will be V I1 cos phi 1, right? Similarly, V I2 cos phi 2. So Q1 will be V I1 sin phi 1 because it is in phase quadrature, right? Correct? Yes. Next, it will be V I2 sin phi 2. Okay? And S1 will be square root P1 square plus Q1 square. Similarly, it will be P2 square plus Q2 square. Now, I have given you all the equations. Now, my expectation is since we have already solved this type of numerical and I have already given you all the values, please put the values and calculate the answer. Okay, let me just specify that the active power comes in kilowatt, reactive power comes in kVAR, and the apparent power comes in kVA. Please remember these things and calculate the values. You just have to put the values, everything is with you. You just have to do the calculation. Fine? Yes. So let us go to the next question now. Question number 6 says, draw and explain the phasor diagram for practical transformer. 6 marks. Now again, when we did transformer chapter, which is chapter number 4, we have already covered this particular topic, phasor diagram for practical transformer. Okay, and we took lagging also. Lagging means when the load is inductive, and we did for leading power factor also. Okay, please refer to that chapter. 6b says find the average value and RMS value for this waveform, and it has been asked for 10 marks. Now exactly the same numerical with same value was solved in chapter number 2 AC circuit when we did average value and RMS value. Okay, so you can refer to that. And the third part, which was asked for 4 marks, says state and explain Thevenin's theorem and Norton's theorem. Again, in chapter number 1, we did this Thevenin's theorem and Norton's theorem in detail. So you can refer to that. Fine. So with this, we will stop today's lecture, and we have completed May 2019 question paper with this. Let me remind you that the syllabus was changed in the month of July. Actually the new syllabus was implemented from academic year 2019-2020. So this examination, May 2019 and the previous ones were based on the old syllabus. Okay, so you might not find any question on 3-phase and single-phase induction motor because that was not the part of this syllabus, earlier syllabus. Okay, so we shall be meeting in the next class with one more question paper. Till then, keep studying. Thank you.